Hi folks, this is Jack Summers from Smoky Mountain Scientific, and I want to talk to you today about methods for making aluminum plates to hold structural parts of your projects. So there's a couple of ways you can do this. You can get yourself a CNC mill. This is one that I purchased as a kit and put together. It cost me about $1,000, well, a little less than $1,000 when you put into it all of the parts, like a router. It uses a router on this assembly that goes up and down and goes back and forth on this, and then the project goes back and forth in the other direction with in that direction. Okay, so that's one way of doing it. That's probably the best way of doing it, but in terms of cost, I'm going to tell you about an easier way. All right, so the idea here is that you make a PDF file that you can then print out at exactly the correct scale. All right, so in this picture you can see that I've made some 3D printed plastic parts that are going to sit on an aluminum plate that has some holes where fasteners go through, and the holes have to be correctly lined up with the holes on my 3D printed parts. All right, so that's our piece of paper. We then cut out the piece of paper, and you can see it's glued to this piece of aluminum stock with a little spray glue. Quite simple thing to do. After you do that, then you come in with a center punch, and you punch where you need to make your holes go. You then can drill it out, and here is a picture of the finished piece. This piece of aluminum, you can see that the holes line up with the holes on the 3D printed plastic parts, and the motor that goes underneath it mounts properly. Everything on this project worked pretty darn well. All right, so the point is that once you get yourself a PDF file, then you're pretty much good to go for making your plate. Okay, so now how do you go about making the PDF file? Okay, to make the PDF file, we've written a program called Template Drawer, and you can find Template Drawer under our Smoky Mountain Scientific GitHub site, https://github.com, Smoky Mountain Scientific, all written out as one big long word. Okay, once you get to that point, you hit Template Drawer, and then you come over here, clone or download, and you can just download the program, and you have to go to www.processing.org, and you can download the processing program for free. Okay, so when you download the simple template, the template drawer, it should look like this. Not sure why I've got a different name here, but apparently I do. Anyway, this template drawer program, it first starts out with import processing.pdf star, and that allows you to work with PDF to generate PDFs using processing. Okay, the next line says string name equals file name.pdf, and that's the file name that you're going to save your file as. Okay, down here somewhere you'll see, okay, in terms of structure, we have a number of different parameters defined, and down here we're going to set up. In setup, we first of all have to specify the size of the window. Then we say begin record, and we're going to record a PDF file. We're going to use that name that we defined above. Okay, down in the draw thing, we have a certain line where we're going to put text in. We're going to give the name of that file so you'll know where to find it. At the bottom of the of the draw file, there's something called end record, and that stopper stops the recording of the PDF. Okay, if we hit the run button here, you'll see that, okay, here is what I've programmed this file to do. I have 1, 2 circles. I've got also this other circle that's part of a group that I'm going to talk about in a bit. We have the name that says filename.pdf. We've got another line of text here, a couple of straight lines that we've programmed in this rectangle, right? If we go through our program and see how we've defined all this, here's one of our lines, there's another line, there's the text that says line 1. You'll see that all these things have some parameters go with them. So the first 2 parameters in the line command tell you where to start. Second 2 parameters tell you where to end. Okay. Down here, the text, line 1 goes at the position 2050. The text name, that's this file name here, says -20, -80. Okay. The ellipse, that's where our circles come in, and they're defined in terms of their position of their center and the radius. It says circle 1 diameter, but that's actually the radius. We entered them and we've done some math on them. Okay, rectangle, that's the position at the center of the rectangle. This is the X size, that's the Y size. All right, so this piece over here is a hole. Okay, so hole, it turns out to be a method that we've defined down here. It's you call a method, you enter the parameters, and then down here it defines what that method does. The method hole requires 2 X and Y positions and a radius defined. Okay, so the X and Y positions are -30, -70. The radius is 10. Okay, now the whole method starts by translating to the X and Y position. Then it draws an ellipse, and then it draws these 2 lines that give you the X and Y position of the center of that hole. It then translates back, and it goes back up here. Okay, if we wanted to put another hole in, we could do that quite easily. Hole, and let's say we're going to put, whoops, don't want that extra space. We want to put this one at 30, comma, and let's say we want it at 30, -30, and let's make this one a bit bigger. We'll say it's got a radius of 20, right? And that radius is 20, what is that called? 20 pixels. Okay. If we want to turn this into millimeters, we can put our conversion to millimeters there. And now when we hit the go button, we'll have a hole position here, which gives us the circle and the XY coordinates, so we know where to drill it. And this is 20 millimeters in size. All right, so it's easy to add features, to define where they are, and that kind of thing. All right, so in addition, I have another function in here, another method in here. It's called NEMA 17. All right, and NEMA 17 is something that draws a template for NEMA 17 stepper motor. Okay, so that's defined on this NEMA 17 tab. We can go back to this, and just for the sake of simplifying the stuff, let us get rid of these 2 ellipses and the rectangle. We're going to comment those out by the double backslash or double slash, and that should clean things up a little bit. Now when we hit the button, we end up with this stepper motor outline here. So if we wanted to put a stepper motor into our design, we just just uncomment the NEMA 17. We tell it where to go, and we also have the option of putting an angle there. So let's say we wanted to put this at a 45-degree angle. We could do that, and now when we hit the button, it comes out at this 45-degree angle. All right, so now we've made this this simple template. This template with a stepper motor and a hole here to maybe bolt it onto our other piece. This might give us the position of some other piece in our design, but now we have to find it, right? And what we do is we go to our file where we've saved this, and okay, so when we go here, we go to Save As, and it'll tell us the whereabouts of this. Oh, it's under Jack Summers, My Documents, Templates. Okay, so we don't need to save it now, but we can go to Summers, My Documents, Templates, and here is the simple template, which is what we've been working with, and it is called File Name. Opening that PDF gives us the PDF file that we just defined. If we say print, hopefully this won't take too long. All right, so this print, we can print it out actual size. We can print it out to 100% scale or 200 or whatever, but actual size is what you want to use. Don't fit it to the sheet because that will give you the wrong size, right? So now we are ready to print it. We could print it, but I don't really see any point in doing that. All right, so hopefully this is something that you will find useful, and yeah, good luck with your making and your projects.